Hi, this is a continuation of the video on turbine. In the previous videos, we have already looked into the introduction, energy transfer, construction, and now we are going to look into compressor turbine matching and part of the materials. With regards to the compressor turbine matching, as you all know that the compressor and turbine are interconnected via shaft. So the flow characteristics of the turbine must be carefully matched with those of the compressor to obtain maximum efficiency and performance of the engine. If, for example, the nozzle guide vanes allow too low a maximum flow, then a back pressure would build up and causing the compressor to surge. Too high of the flow would cause the compressor to choke. So these two situations has to be controlled. In either condition, a loss of efficiency would very rapidly occur. Now, we look into the materials of the turbine. Among the obstacles in the way of using higher turbine entry temperatures have been always the effect of this temperature on the nozzle guide vanes and turbine blades. As we all know that from our previous topic on the performance, the higher the turbine inlet temperature, that the better the thrust or the higher the thrust of the gas turbine engine. So you want to have a higher inlet temperature. So the high speed of rotation, which imparts tensile stress to the turbine discs and blades, is also a limiting factor of the turbine. We shall look in more detail about the materials for nozzle guide vanes, and we will continue on turbine discs as well as the turbine blades. Due to their static condition, the nozzle guide vane as shown here do not endure the same rotational stresses as the turbine blades. Therefore, heat resistance is the property most required. Okay, you want a heat resistant. And nickel alloys are normally used, although cooling is still required to prevent melting. And there are cases ceramic coatings are also being embedded or being coated on the nozzle guide vanes to enhance the heat resisting properties. For the same set of conditions, reduce the amount of cooling air required, thus improving engine efficiency. Now we look into the turbine disc. A turbine disc has to rotate at high speed, okay, in a relatively cool environment. So it needs a cool environment and is subjected to large rotational stress because it is being rotated. So the limiting factor which affects the useful disc life is its resistance to fatigue cracking. So in the past, the turbine discs have been made in ferritic and austenitic steels, but nickel-based alloys are currently being used. Increasing the alloy elements in nickel extend the life limits of the disc by increasing fatigue resistance. Alternatively, expensive powder metallurgy discs, which offer an additional 10% of strength, allow faster rotational speeds to be achieved. So that can be used in a modern turbine disc. We shall continue in the next video, which is the last video, to look into the turbine blades material. Thank you for now. Bye-bye.